what I'll give you here in this first paper is more of an overview of what the team has done and how we set up everything. The next 3 papers, you'll hear a lot more depth into the data that we've seen, or the initial data that we've seen. So what I'll talk to you about is the overall structure of the program, what we did about a test vehicle, how we established procedures for producing comparable data. And that's a really important point here, because we have data that's being developed across many, many different facilities. And in order to take all of that data and look at it in one package, we needed to be very careful and make sure that that data was comparable. I'll talk a little bit about the assembly and the thermal cycling that we did, about what silver concentrations we were looking at, and what those silver concentrations ended up being in some of our calculations, and then a current status of where we are in the thermal cycling, and then I'll let you get to the meat of what's going on with my 3 colleagues coming up.
Now, what we're going to do in the workshop is based on the information from the PERM, the Lead-Free Electronics Reliability Consortium that was put together, I believe now it's been about 3 or 4 years ago. There were 3 phases to it. Actually, 2 are published in documents similar to what you see here, addressing all aspects of lead-free reliability as it would pertain to high-reliability electronics. For example, DoD, space, and other similar applications. The first part of that project looked at all the aspects of lead-free, and then the second one began to digest down and start to rank what are the important factors and what are the second tier and third tier. So in terms of importance and criticality to high reliability electronics, certainly the phase 2 is as important as the first.
So this talk is about lead-free reliability testing from the point of view of design and manufacturing, and trying to take advantage of the test results and treating them as historical data so that they can be used in the future for new designs or upgrades. It's kind of a standard reliability talk, except that the test vehicle in itself is very interesting with a mix of components and parameters. Then I'll go over the test conditions and the results, viable characteristic lives, and so on. A little bit of discussion on the failure mode analysis and their so-called stochastic predictive model, which is more like an empirical model which correlates the characteristic life in test to the parameters that they were varied in the experiment. So it's a very simple statistical, but first order relationship to look at the effect of the solder paste thickness, stencil opening, component size, and so on.